So far, we've already talked about what is slope and how to find slope. Now we need to talk about slope when it involves parallel lines, okay? So the first definition is two lines are said to be parallel if they never intersect, okay? So if you had a line kind of like this, and then a line like such, assuming these lines go on forever and ever and ever, they never intersect, they would be considered parallel, okay? In other words, two non-intersecting lines have the same slope, okay? They just are in different locations, but they have the exact same slope, and that's really, really, really important to understand. So parallel lines have the same slope, all right? So for example 3, it says, determine if the lines through each pair of point are parallel or not. So for part A, we've been given line 1, and what they've done is they've given us 2 points on the line, and then they've given us line 2, again, 2 points on line 2. Let's calculate those two slopes and then see if they're the same. If they're the same, we could say these two lines, line 1 and line 2, are definitely parallel. If they're not the same, they're not parallel. So for line 1, okay, we're going to do the slope, which we know is m equals y2 minus y1 over x2 minus x1, okay? Well, if we label this -2 as x1 and 0 as y1, and then 0 on the second point as x2 and 6 as y2, I get 6 minus 0 over 0 minus -2. Always be careful when one of your coordinates is negative, especially if you're subtracting that, it becomes addition. So we get 6 minus 0, which is just 6. 0 minus -2 is 0 plus 2. So we get 6 over 2, which is 3. So that's the slope for line 1. Now let's look at the slope for line 2. And remember, every time you write down the slope formula, if you write it down every time you use it, it just helps you remember it quicker. So we'll do that for now, and then eventually I'll kind of start to skip that step. But we're going to go ahead and say that 1, 8 is going to be x1, y1 for that second line. 0, 5 is going to be x2, y2. So when we calculate the slope, we're going to take y2, which is 5, minus y1, which is 8. We're going to divide that by x2, which is 0, minus x1, which is 1. Well, 5 minus 8, I forgot to write down the formula. 5 minus 8 is -3. 0 minus 1 is -1. We get a slope of 3. Since the slopes are the same, they're the same, we would say these two lines are parallel. So L1 is parallel to L2, L2 is parallel to L1, okay? Let's see what happens in example B, or part B of example 1. So we have L1. Let's go ahead and label the points x1, y1, x2, y2. And then for our slope, remember it's y2 minus y1 equals x2 minus x1. So let's see, y2 is 5, y1 is 3, so I get 5 minus 3. X2 is 1 minus x1, which is 0. So let's see, 5 minus 3 is 2. 1 minus 0 is 1. So for L2, or L1 rather, we get a slope of 2. Now let's repeat that whole process, but this time we're going to look at L2. So for L2, again, we have m equals y2 minus y1 over x2 minus x1. And let's label those 2 points for L1. So let's see, we get x1, y1, x2, y2. So when I fill those numbers in, I get y2 is 10 minus y1 is 7. And then I get x2 is 1 minus x1, which is -1. So watch those signs there. So I would get, let's see, 3 over 2. And 3 over 2 is not the same. So we can see here, not the same. So we would say not parallel. All right, well, let me write that as parallel with an L. So you have an example here where you can see a situation where two lines are definitely parallel, and then a situation where your two lines for sure are not parallel. And in the same video, let's go ahead and talk about topic 3. It's very similar. So topic 3 for this worksheet is slope and perpendicular lines, okay? So for the definition, we have two lines are said to be perpendicular if they intersect forming right angles. So if we had a line like this, and then a line like this, we would say these two lines are perpendicular because we have formed two right angles. You'll also see two lines that completely intersect. and they form 4 right angles. All right, you just have to have that formation of right angles for lines to be perpendicular. Now, some more information. The slope of perpendicular lines have a product of -1. Okay, so you have to know that if you take a line's slope and then a line that's perpendicular to it, and you take that slope and multiply them, the product will be -1. So the slopes of perpendicular lines, if we go a little bit further, are opposite reciprocals of one another. Now remember, if I have a fraction, let's say it is a over b, the reciprocal of that fraction is b over a. Okay, so a over b, the reciprocal of that would be b over a. But in this case, we want opposite reciprocals. So one of the two reciprocals would have to be negative, one would have to be positive. Okay, so let's go ahead and do the same thing here. It says, for example, determine if the lines through each pair of points are perpendicular or not. So let's look at L1. We'll go ahead and label the points x1, y1, x2, y2. And remember, slope is y2 minus y1 over x2 minus x1. So let's see, for y2 we get 3, y1 is 5, so we get 3 minus 5 for the change in y. x2 is 0, x1 is 1, so I get 0 minus 1 for the change in x's. When we simplify, 3 minus 5 is -2, 0 minus 1 is -1. That simplifies to 2, okay? Let's look at L2 now. So I'm going to go ahead and label those points x1, y1, x2, y2. And then we know that m is y2 minus y1 over x2 minus x1. And let's see here. For the y's, we get 6 minus 8. For the 2's, we get 2 minus -2. Watch those signs there, okay? 6 minus 8 is -2. 2 minus -2 is really 2 plus 2. So I get -2 over 4. You would want to reduce this, and we would reduce to get -1/2. Well, if you think of 2 as 2 over 1, the reciprocal of 2 over 1 is 1/2. Notice that 2 is positive, 1/2 is negative. These are definitely opposite reciprocals. So we would say that these two lines are perpendicular. And it didn't really fit, so I split it, but you get the general idea, okay? So let's do the exact same thing, but we're going to look at this example B. So we're going to look at 2 new lines. So for L1, let's label the points x1, y1, x2, y2. And m is y2 minus y1 over x2 minus x1. So let's see, I get 9 minus -6. Watch those signs. 2 minus -1. So the numerator is really 9 plus 6. The denominator is really 2 plus 1. So let's see, I get 15 over 3 or 5. So the slope of the line that we've labeled L1 is 5. Let's talk about L2. So remember, slope is y2 minus y1 over x2 minus x1. Hopefully you're starting to already memorize that formula. All right, let's label our points. We have x1, y1, x2, y2. When we fill in the numbers, let's see, we get 3 minus -1 for the y's. We get 5 minus -15 for the x's. And remember, when you subtract a negative, it just becomes addition of a positive. So we really have 3 plus 1 over 5 plus 15. So that's 4 over 20, which is 1/5. Okay, now be really careful here. Yes, we have reciprocals. So these are indeed reciprocals, but they're not opposites. So when you say opposite reciprocals, one has to be positive, one has to be negative, but not opposite reciprocals. So we would say these are not perpendicular. Close, definitely have the reciprocal, but if we were to graph these two lines, they would intersect at some point. So there you have it. That is how you can determine if two lines are parallel or if two lines are perpendicular. This could come back later, and this could come back up later in this course. But for now, just understand two lines are parallel if they have the same slope. Two lines are perpendicular if they have opposite reciprocal slopes. So again, one has to be positive, one has to be negative.